So first of all, before I do this question, I think it's actually important to give this question some context. It's really nice that the SMC is linked into a bit of maths research that's actually very recent. So this tile, it says it can be used to tile the plane, and I've actually started it off. I've got my tile here, and I kept rotating it and trying to make it fit, and it looks like it is. And it's actually possible to continue this tiling, but not in the normal tessellating pattern where it always like looks the same, like a square you can just repeat in space. In fact, this tiling doesn't repeat, it's aperiodic. And in 1974, Roger Penrose showed that 6 tiles could be used, and then he reduced it to 2 tiles. I'd look into those, that they're quite interesting. And it's only in November 2022 that David Smith, an amateur mathematician, discovered this hat tile, so it's a single tile that manages to do an aperiodic tiling of the plane. And he got some help from some mathematicians, one of which is involved with the UKMT, to prove that it is necessarily true. So it's actually maths being done at the present time that, yeah, people have been, trying to search for these for a long time. And the fact that when Penrose came up with these, like they were big deals. And so in some ways this is an even bigger deal because it is possible to do it with a single tile. I'd strongly urge you to read a little bit more into this. Okay, onwards with the question. We're told that this hat tile has an area of 8 root 3 and it's made up of 8 congruent kites. That means each kite is going to be root 3 in area. So let me draw one of these. It looks something like this. And we want to work out the perimeter of the hat tile. So maybe I call this X, this blue length. And so I've got 1, 2, 3, 4, 5, 6, 7, 8 X. That's what I want to find. And then this one is Y. 1, 2, 3, 4, 5, 6. We need to find 8X plus 6Y. Okay, well, you can see that there's an angle around a point here of 360, and it's 3 of these angles, so that must be 120 degrees. And the similar reasoning, we've got an angle around a point with 4 of these, so these must be 90. Okay, and that makes life so much easier because I can draw a line down the middle. I've created a right angle triangle. The area is actually going to be a half times x times y for one triangle times by 2. Actually, xy is equal to the square root of 3. Okay, and because I've drawn a line down the middle, we've now got a 60-degree angle here. Actually, let me draw it separately. So I'm just going to change the orientation slightly, kind of turn this one around. So y is now on the bottom, x is here, this is on 90, and this is going to be 60. So I can also use the fact that tan 60, which is by the way root 3, is equal to x over y. And we've got simultaneous equations with basically there. So y is going to equal root 3x, and that means I can replace it here. Um, so I've got x squared root 3, which means x is going to have to equal 1, and y is going to have to equal root 3. Put that into here, we're going to get 8 plus 6 root 3, giving us our answer of E. If you don't know exact trig, you could alternatively realize that you could put the two triangles together, draw the other one down here, and create an equilateral triangle. So that will be 30, that will be 60, and then what do we have? We've got, yeah, this is going to be x as well. This is going to be, therefore, 2x. And you could use Pythagoras to get y. You could do 2x all squared minus x squared, square rooted, which would again give root 3x. It's not absolutely essential. If you haven't covered that topic yet, you can still do this question just by realizing it's an equilateral triangle. I think, yeah, you do need to recognize that to be able to relate the two together. Okay, really nice question and a nice bit of maths going on. Well done.